Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Walker Grant Middle School. And in this video, what we're going to be working on is kind of reading through some of these word problems and being able to not only set up an inequality, but be able to solve it as well. So make sure that you're, reading very carefully how these work and seeing, what type of answers that we will be getting. So for the first one, it says Sarah goes to a university. She has $900 in her savings account. She needs to buy a small laptop computer before the next semester. The laptop costs $600. Each week, she withdraws $60 from her savings account for food. How many times can Sarah withdraw money for food? So usually what I do is I read through it once, and then I can kind of go through it and maybe either highlight or underline some ideas that we have. So some values that I do want to use, I'm going to say that she has 900 in her savings account, and then the laptop is $600. And then it says that she each week, so maybe let me say each week she is taking out. So make sure you're saying withdraw. Again, she is taking out money from her savings account for food. So how many times can she do that? Well, let's maybe set this up. So I'm going to set it up like this. I can say that I'm going to have, I can't spend money I don't have, so I'm going to have to spend, I can spend at most. And so I'm going to use those keywords that I have out there. I'm going to spend at most $900. So any of my values over here have to be less than or equal to 900. So I'm going to have 600 for the laptop, and I'm going to say I have 60 times x, where x is the number of times they can withdraw for food. So my inequality is going to be like this. It's going to be 60 times x plus 600 is less than or equal to 900. And so if I take that inequality, I can now solve for it. So that way we can figure out our answer. So I'm going to say 60x plus 600 is less than or equal to 900. Again, be able to do your inverse operations. I subtract 600 from both sides. So subtract 600 from both sides. On the left side, all I have is 60x, and on the right side we have 300. So I have 60x is less than or equal to 300. And my last step, again, most of these are just going to be one or two steps, but you want to make sure you can set it up carefully. So I divide by the coefficient, and I'm going to say x is going to be less than or equal to 5. I can always double check. I can say 300 divided by 60 is going to be equal to 5. So now, how do we translate that back to words? Meaning this. It's asking how many times can Sarah withdraw money for food. So we could say this. She can withdraw at most. At most. Again, that keyword at most meaning less than or equal to 5 times. So make sure you're able to, switch from the passage to an inequality and then come to a conclusion. For the next one, it looks like this. It says you want to get an Uber for a trip to DC. The trip costs $700 to start out with for the night and 15 cents per mile. You will have $750 to spend. Write an inequality that represents this scenario. How many miles can the Uber travel? So let me change this. It should be 20 cents. We actually had a high demand, so we're going to say this is going to be, let's do it like this. Let's have shape, and let's just put $. 0.20. So we're going to say 20 cents per mile. You'll have a total of $750 to spend. Write an inequality that represents this scenario. How many miles can the Uber travel or take you? So again, when you are saying this, you want to make sure that you're highlighting some ideas here. So again, it has 700, has the value of 0.2 and 750, but you want to make sure you're also looking at those keywords. So it says you have 750 to spend, so make sure you're not spending money that you don't have. And then also too, you want to see that saying per mile. So that usually means multiplication or division. And so when I have this, I can write it like this. I'm going to have 0.2. I have 0.2. So 0.20 for my per mile. And it's asking about how many miles do I have. So I'm going to let X be my miles. I'm going to let X be miles. And it says that I'm going to it costs $700 for the night. So that's going to be my cost, and I can't spend more than I have, so I can spend up to and including $750. So that's going to be my inequality, and so now I can take and say this. I would say I have my inequality 0.2 times x plus 700 is less than or equal to 750. You can make sure you can use your inverse operations. Subtract 700 from both sides. On the left side, I have 0.2x is less than or equal to 50. Usually when you divide by a decimal value, it's going to have a larger number. And so I should get even though I am dividing, I'm going to get a larger number. So let's actually do it like this. I'm going to say I have x is less than or equal to, well, let's double check. I have 50. I have 50. I have divided by, we say 0.2. And so it's going to be a total of 250. So I'd say x is going to be less than or equal to 250. So I can go up to 250 miles. So make sure you put that label on that. So I'm going to say I can go up to, or at most, 250 miles. For that next one, this is a true story. Tyrell wants to pass 8th grade math and go to JM. His math grades are as follows for the first 3 quarters. So if at first he got a 61, a 35, and a 66. If he needs to get at least 60 for the entire year, then what grade does he need to get for quarter 4? So this is a real life situation. You want to make sure that you can kind of figure out what you need to get. And so, for example, I helped out a student and I said, well, if you can solve this problem, we can make this work. So if you're talking about that those are the 3 quarters for the entire year, so again, let me kind of highlight some of these ideas. So I have 61, I have 35, and 66. And then it says at least 60, so I need to have that is going to be a key part there. But also make sure you're saying for the entire year. So let's set it up like this. Let's say 61 plus 35 plus 66. And then we're going to say we don't know what that quarter 4 is going to be, so maybe let that be x. Since it's the entire year, again, quarters, there's 4 of them, so I'm going to divide this by 4, because that would get your average for the entire year. And since it says at least, that means I'm going to have greater than or equal to 60. So they need at least a 60 to get through up to JM, and so that's going to be our inequality. If that is our inequality, again, I can set up like this. I'm going to have 61 plus 35 plus 66 plus x, all divided by 4, is greater than or equal to 60. Again, I can now do my inverse operations. So kind of like that IXL section, I can multiply both sides by 4 first, so that way I can get rid of that division. So now I'm going to have those values, which let me actually add those together on the side here. If I add these values together, I have 61 plus 35 plus 66. So I'm going to have 162. So I would say I have 162 plus x is going to be greater than or equal to 240. Be able to subtract both sides by 162. 62. And so I'm going to say they need to get at least. So I'm going to have x is going to be greater than or equal to, x is greater than or equal to a 78. So they would need at least a 78 in that fourth quarter to get a passing grade of 60. So they need, so we could say this, we'd say Tyrell needs at least a 78 in quarter 4 to pass the year. And since this is a true story, it all worked out, and he actually got an A for that quarter, and he passed for the year. So I was real proud of him for that one. For number 4, it says Jorge makes $9.50 an hour working at a shoe store. He wants to buy a skateboard that costs $110. How many hours must Jorge work in order to purchase his skateboard? So make sure that you're saying not only those values are important, so I'm going to have 950 and 110, but you have to also understand it's per hour. So it's each hour that they work, it's getting 950. So you have to have a full hour to get that $9.50. So then it's asking how many hours must they Jorge work in order to purchase the skateboard. So I'm going to set up my inequality like this. I'm going to say, well, if it's $9.50 an hour, I have $9.50 per x, where x is the number of hours. And I need to say I need at least $110 to get it. So again, when you solve this is a simple one-step equation. However, you want to make sure that you're understanding what it is coming out of it. So I'm going to divide both sides by 9.5. Divide both sides by 9.5. And so I can say that Jorge needs to work at least, let me put this. So he would say, I think it's a crazy number, but let me double check. So I have 110 divided by 9.5. And so yeah, you get this kind of crazy number. So I have 11.57 and then some values after it. And what is that saying? Well, I said this, I have to have a full hour. So what would we have to do? Well, we're going to say, some people would want to say, well, it's just 11 hours. And that's not the case because I still have that extra amount. So I could say this, I would say, let me put down here. I'd say Jorge has to work at least, and so that's the key part right there. At least 12 hours to buy the skateboard. Buy the skateboard. And where did I get that 12 from? Well, I said that it has to be a full hour, and so what would be the next hour up? It would be 12, and so that means that if they would only work 11 hours, it wouldn't be true, meaning he wouldn't have enough money. So I can also prove it like this. I could say, 9.5 times
what do we say? Well, it would be at least 11 hours. But that's not the case. Look, he's still short. He doesn't have enough money. So you need to make sure that you were saying it would be at least 12 hours. So then once he had 12, he'd be able to pay for the skateboard. For the next one, it says an excavator charges $50 to come to Tony's home, in addition to $45 per hour for the service. Tony has less than $275 spend on preparing his yard for a patio. How long can Tony afford to hire the excavator? So let's highlight some values that we have. So we have 50. We have the phrase in addition to, so we know we're going to be adding. We have $45, and it also has per hour, so we know we're going to be multiplying or dividing. And then also it has that phrase strictly less than. So he has less than $275. So now we are going to say this. We're going to say, all right, our inequality can set up like this. We would say $45 per hour. So we're going to say times the number of hours, where X is hours, in addition to, so we have plus the $50 original charge. And it says less than, so we need to actually have strictly less than, because we can't spend that much, but we can spend less than that much. So it's spend less than $275. So we'd set it up like this. So make sure that you are seeing it carefully. So we need to have a value that is going to be less than that amount. So we have 45 times x plus 50 is less than 275. Again, you can subtract both sides by 50. Subtract both sides by 50. And so I have my inequality as this. I have 45x is less than, let's actually draw that symbol correctly, less than 225. Now we can divide both sides by 45, always divide by that coefficient. So we divide both sides by 45, and so I have 225 divided by 45 is going to be 5. So I'd say x is less than 5. So I could say this, since they're working, full hours, it'd say they'd be able to work less than 5 hours. So what would be the only other whole hour? We would say that we'd say this. We'd say Tony can afford to hire them for 4 hours. And where am I getting that 4 from? Well, I'm getting that 4 since 4 is less than 5, then we know that we could hire them for sure for 4 hours. Since the next hour up would be 5 hours, we can't do that much because we wouldn't have that much to spend. For the last one, it reads like this. It says, Tony's Fun Park charges $20 per car and $6 for each person in the car. What is the maximum number of people that can go to the fun park in one car? For $70. So let's highlight some values that we have. So we have 20. Again, we have per, so we're going to say probably going to be multiplying. We have $6. We also have for each, so maybe we got to be very careful when we have this. And then we're going to have that 70 there. So what are we looking for? Well, we're saying at maximum number of people. And it actually already tells us how many cars we have, so we don't even need per car, so because we know how many cars we're going to have. So I can actually take that part away. So I'm going to say this. I'm going to say it's going to be $6 for each person. So I'm saying 6x, where x is the number of people. And it's going to be $20 for that one car. So how many maximum people? So at maximum, so I'm going to say it could be including, so I'm going to say less than or equal to, and then $70. I keep writing 75, but it's just $70. So if this is my inequality, make sure you can set it up on the right side. That way you can solve it.
And so I have it like this. Again, subtract 20 from both sides. I have on the left side 6x is less than or equal to 50. And so I have my last step being this. I would divide both sides by a coefficient, which is 6. And so I'm going to say my inequality can look something like this. I'm going to have 50 divided by 6. It's going to be 8.3 repeating. Well, hopefully you don't put part of a person in there. And so at maximum, we can have 8.3 people. However, I don't want part of a person. I want a whole person. And so we could say the maximum, the maximum number of people is 8 whole bodies. 8 whole bodies. So again, make sure you're very, very careful when you are setting these up. Make sure you're using that Desmos calculator to check and see how those work. And as always, super slam that subscribe button.